Welcome back to CircuitMeter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in.
Today, we are putting on our industrial safety glasses and diving into the engine room of global commerce, manufacturing. We're tackling one of the biggest, most persistent financial drains out there, industrial energy waste. The stakes here are just enormous. When we talk about industrial and manufacturing sectors, we're looking at consumption that accounts for something like 37% of global final energy use. It's huge, but here is the core, really frustrating problem. Most of these facilities are financially compromised because they are operating, what we call flying blind. They know their massive dollar amount on the final utility bill, sure, but they lack that forensic ability to drill down and see precisely which specific machine, which circuit, or which process is the actual culprit. Where's the waste actually happening?
And that lack of visibility, as the sources really detail, it results in chronic data poverty. It's a real issue. Plant managers, engineers, CFOs, they face significant internal barriers. You've got financial constraints, sometimes skill gaps, and just the sheer cost and complexity of existing infrastructure. It was never built for this level of, data collection. So you end up with these pervasive hidden costs that traditional methods they simply cannot catch.
Okay, so we have data poverty meeting high-cost energy consumption, a tough mix. Our mission today is to dive into the technology that aims to solve this, specifically looking at CircuitMeter's approach, which they call forensic energy management. But let me ask you this. If I'm a plant manager, I already have a main utility meter at the front door. Why do I need forensic metering? Isn't this just, expensive sub-metering again?
Well, that's where the breakthrough technology really comes in and why it's described as forensic, not just auditing. An analogy might work best here. Think of your utility bill like your monthly bank statement. It tells you the final balance, right?
Okay, yeah, the big number.
CircuitMeter system is more like the detailed transaction log for every single purchase you made. It provides complete electrical metering across an entire organization's portfolio, right down to the individual circuit level.
Down to the circuit.
Exactly. And what makes this revolutionary is really two things. First, the cost structure. It's designed to be a small fraction of what legacy submetering systems typically demand. That's key. And second, the speed. It delivers instant granular data via the cloud. We're talking every 2 seconds.
2 seconds.
This level of hyper-detailed, real-time energy visibility is what transforms energy management from, guesswork into an actual science.
Okay, let's start with the first, maybe the most immediate gain from that kind of hyper-detailed data, stopping the constant everyday bleeding of energy waste. I'm thinking less about, say, major equipment failure and more about the simple human errors or system setting errors that just go completely uncaught.
Yeah, and that's often where the biggest, easiest savings are actually hidden. We're talking about pervasive, totally preventable waste. The sources highlight operational errors quite a bit, settings issues, control systems, running things unnecessarily. Think of a common scenario. Maybe due to a small, uncaught error in a control system, the cooling unit is fighting the heating system in a specific production zone for a whole week. Or maybe a large motor in the paint shop is left idling over a 3-day holiday weekend.
Right, and without circuit-level metering, those kinds of errors are just absorbed. They vanish into the overall utility bill. It's like an invisible phantom load.
Precisely. CircuitMeter's circuit monitoring platform functions essentially as a continuous energy audit running 24/7. Because the data is so granular, managers can be instantly notified when specific equipment or systems are running when they shouldn't be, or maybe consuming more energy than their established benchmark. You avoid the high cost of those periodic energy audits that, let's face it, only capture a snapshot in time and usually only cover a small percentage of the facility anyway.
Okay, here's where it gets interesting beyond just, zapping waste. This concept of precision benchmarking and preventing performance drift. Tell me about that.
Well, precision is really the entire value proposition here. The system makes it possible to benchmark the exact ideal power use for all your equipment. It's not just about comparing your facility to the one next door, but comparing, say, machine A to its own ideal operating state. That specific energy signature for optimal performance becomes the benchmark you track against.
Okay, so if machine A starts consuming, say, 10% more power than its benchmark to do the exact same amount of work, even if it's not actually failing yet, you'd catch that drift instantly.
Absolutely. That 10% drift could be anything, maybe early friction developing, miscalibration, or simply inefficiency building up over time. The continuous monitoring catches this kind of deterioration immediately, not weeks or months later. And this data isn't just about the hardware either, it's also about the people operating it.
That's often the hardest part, isn't it? Modifying behavior. How does this technology actually move the needle on staff engagement with energy saving?
It really connects energy use directly to accountability, which is critical. The system allows managers to break down usage information to specific sections of a floor or an individual production line, or even track it on a per-shift basis.
So you could actually tell the second shift team.
Exactly. Providing that kind of regular, detailed usage feedback is the key to modifying behavior. When energy targets become a measurable part of a group's performance objectives, the workforce can transform from, well, maybe ignoring waste to actively hunting for savings opportunities.
Okay, so if that first pillar was about stopping the sort of operational bleed, the next big challenge is taming the unpredictable volatility of utility costs. I'm thinking specifically about peak demand charges and those tricky power quality penalties.
Oh yeah, these charges are the real hidden fees on an industrial utility bill. Peak demand charges. They can represent up to 40%, maybe even more, of the total bill, depending on the region and the specific utility tariff. Every facility manager knows that their peak happened, but the fundamental frustration is often not knowing what exactly caused it or when it happened in real time to perhaps prevent the next one.
Okay, but hang on. If I'm running a plant with dozens of massive motors, I know that when I start them all up simultaneously, that's going to cause a peak. Why do I need circuit level data just to confirm that obvious point?
That's a fair question. Because your biggest problem isn't usually the single plant startup you account for that. It's often the unexpected confluence of multiple loads hitting at the same time that causes the highest, most expensive spike. CircuitMeter provides really granular demand analysis that pinpoints the precise makeup of the peak demand, down to the second it occurs. This allows managers to understand if the peak was caused by, say, a specific batch process kicking in, maybe an uncoordinated machine start somewhere else, or even a specific piece of ancillary equipment like HVAC cycling on at the wrong moment. With that level of insight, they can then implement targeted load shedding or specific behavioral or procedural changes, maybe shuffle loads around a bit to save tremendously on those extremely high demand charges.
Got it. And the data quality itself needs to be pretty robust to handle complex industrial systems, right? We're not just counting kilowatt hours here. We're talking about the quality of the electricity itself, things like power factor.
Exactly. The sophistication of the data capture is critical for industry. The WebMeter 4080 unit, for example, calculates up to 334 distinct data points for every single 2-second update. This includes real power, consumption, voltage, frequency, and critically, power factor.
Okay, and just for our learner audience, power factor is essentially a measure of how efficiently your equipment is using the total power the utility delivers to you. If your factor is low, you're drawing more total power than you're actually converting into useful work, and the utility often penalizes you for that inefficiency, right?
That's a perfect description. Low power factor often stems from things like older motors, equipment that might be improperly sized for the job, or just general electrical system problems. It results in utility fines that can easily run into the thousands of dollars every single month. Continuous monitoring enables immediate identification and analysis of these electrical characteristic problems as they actually occur. You get the hard data necessary to justify and implement power factor correction measures, potentially eliminating those persistent hidden penalties entirely.
All right, let's pivot to our final pillar then, which is really about turning all this energy insight into operational resilience and solid financial proof. This ties directly into maintenance strategies. Equipment wear, like failing bearings in a motor or maybe scale buildup on a heat exchanger, that kind of thing, almost always leads to increased power consumption before you see an outright mechanical failure.
Yes, and this is where that forensic data becomes truly predictive. We can move past just standard preventative maintenance, which, let's be honest, often means replacing parts before they actually need it, leading to over-maintenance costs, and move into what we call precision maintenance. With a system like CircuitMeter, customers can set custom threshold values for every single monitored circuit.
Okay, so for example, if a specific motor normally draws 50 amps when it's running at full load, and the system suddenly sees it consistently drawing, say, 60 amps under the same conditions, that threshold is tripped.
Precisely. If energy use spikes unexpectedly due to mechanical deterioration or some kind of malfunction, a real-time email notification is instantly generated and sent to the right people. You're catching component failure in its early stages, long before it causes a catastrophic unscheduled shutdown. And for a major automotive plant or a continuous processing facility, just 1 hour of unscheduled downtime can easily cost upwards of $20,000, maybe much more. Avoiding even one single unscheduled shutdown event like that can potentially pay for the entire monitoring system multiple times over.
That focus on just-in-time maintenance makes sense. It avoids both the huge costs of unexpected downtime and the wasteful spending on replacing parts that still have useful life left in them. But after all this smart data collection and intervention, you absolutely have to prove the ROI right, which brings us neatly to measurement and verification, or M&V.
M&V is absolutely foundational for strategic energy decision-making. You need irrefutable data to confirm that the energy efficiency investment you made, whether it was upgrading the HVAC system or replacing a line of old motors, actually delivered the savings that were promised in the business case. CircuitMeter's reporting tools are designed specifically to provide the accurate, validated data required to assist energy audits and, crucially, to prove the return on that capital investment. Without this solid proof, getting funding for future efficiency projects often stalls out.
What's fascinating about this whole solution, thinking back to my first question, is the scalability. We started by talking about how traditional submetering could be expensive, but this sounds like it's really designed to be deployed facility-wide, maybe even enterprise-wide across multiple plants or sites. How does it interface with the existing control systems that managers already rely on daily, like their SCADA systems?
Yeah, the solution is explicitly designed for enterprise-wide portfolio management. It scales very easily, from monitoring just a few critical assets in a smaller facility right up to vast industrial complexes with thousands of circuits. And crucially, that real-time high-frequency data is not trapped in some proprietary silo. It's designed to interface seamlessly with existing control systems like building automation systems, BAS, or supervisory control and data acquisition, SCADA systems, typically through its open API. This connects the energy analysis layer directly to the operational control layer, meaning you could potentially automate responses based on the real-time energy data.
Interesting.
And just as a strategic bonus, the system can automatically convert that energy consumption data into CO2 equivalent, or CO2e production data. This quantifies greenhouse gas emissions linked to energy use, making it instantly supportive of increasingly mandatory sustainability and ESG reporting requirements.
Okay, so to kind of bring this deep dive home, the core idea here is that CircuitMeter provides hyper-detailed energy insight. We're talking real-time circuit-level data, but at a cost structure that makes facility-wide deployment finally seem achievable for many.
Exactly. They enable facilities to move away from relying on the guesswork and the, frankly, historical lag of the traditional utility bill, and towards the data-driven certainty of what they term forensic energy management. This provides a continuous audit capability that helps minimize waste, can dramatically cut those peak demand costs, and helps prevent costly operational disruptions. It really makes energy usage visible, genuinely manageable, and controllable.
Yeah, it seems this level of insight could transform energy management, moving it from being just a reactive cost center that kind of accepts the monthly bill as inevitable into a continuous, measurable, and strategic advantage that directly improves productivity and overall competitiveness.
And if we connect this technology to the bigger picture for a second, it could fundamentally change what's considered a best practice energy management platform going forward. If the central tenet of management is still what you can measure, you can manage, then the next frontier really isn't just measuring the single main meter anymore. It's about metering all the significant circuits in real time, consistently across the entire organization. So the final question we leave you with, especially if you manage or work in a complex industrial facility, is this. What new levels of efficiency, productivity, and ultimately profitability could you achieve if you had complete, real-time energy data for every important process and component in your facility available all day, every day? Something to think about.
And that's it for this episode of CircuitMeter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.